these quadratics? Yeah. What was the very first thing that we did in the first step of graphing quadratics? If you watched the video last night or read the notes, what do we do? No? No? No, that's step 2. What's step 1? Very good. So, does this one go up or down? This one goes down. How do you know that? Yeah, because we have a negative in front. So this one goes down because a value is less than 0. In this case, the a value is negative 1. So that's the first piece of information that we find. This parabola is facing downward. No problem. Okay, the second thing that we find is, who remembers? The vertex. Very good. Now, I'm going to go over the 2 ways in which you can find the vertex. I'm going to show you both of them. You can choose either way, whichever way works for you. I'm going to show you how to complete the square with this particular one. And then I'm going to show you negative b over 2a, comma f of negative b over 2a. And that will give us, you will see these answers will be equivalent when finding the vertex. So complete the square. I like this method. I'm given this. F of x is equal to negative x squared minus 2x plus 1. Now remember, if I'm given ax squared plus bx plus c, I want to get it into the form a times x minus h squared plus k. The reason is because then I can read off the vertex, it's just h comma k. So that's very useful. So the question is, how do I go from this to this? You do that by completing the square. All right, these 2 forms are going to be equal to each other. They're just going to look different, and they have different characteristics. So let's do negative x squared minus 2x plus 1. Let's complete the square. So I'm going to factor out a negative 1. That's going to give me x squared plus 2x plus 1. Does everyone see why the 2x changed signs? Yeah, because I factored out a negative 1. All right. Now I have negative 1. I have x squared plus 2x plus something. I don't know what's going to be yet. Plus 1 and then minus something. So check it out. I am adding and subtracting the same thing. I don't know what it's going to be yet, but I'm going to figure that out right now. Because I need to, the question was, why am I subtracting? Because I'm working on one side of the equation. All of this is f of x equals, right? So I'm never crossing the equal sign. So I need to add and subtract the same amount to keep my equation balanced. Okay? So the number that goes here, we take half of 2, which is 1. And we square that, we get 1. Now you'd want to put a 1 here, but remember you have factored out a negative 1. So you need to multiply negative 1 times 1, which negative 1, that's the number that goes inside the box. Okay?
So it's minus.
Exactly. So when we clean this up, here's what we're left with. Negative 1 times an x plus 1 squared, and then I have a plus 2. This became a perfect square trinomial, which is why it factored to x plus 1 all squared. That should look familiar to you. Great. This is perfect, because now I know exactly where the vertex is. Where is it? Negative 1, comma 2. Very good. Awesome. I also know something else about this particular function and the parabola. What other piece of information is hidden right inside there? The negative 1. Very good. The axis of symmetry is the line x equals negative 1. We're doing great so far. That's one way to do it. I'm a fan of that way. I think that way is kind of slick. There's another way to do it. The other way to do it is negative b over 2a, which is, we start by figuring out a is a value of negative 1, b is a value of negative 2, c is a value of 1. By computing negative b over 2a, I get negative 2 all over 2 times negative 1. That looks like 2 divided by negative 2. That looks like negative 1. Hey, that's exactly what we got over here. Negative 1. That makes perfect sense. All right, now how do I get the 2 out then? What do I do? Very good. I take the negative 1 and I substitute it back in for x. So I'm going to have this. Negative 1 squared, the opposite of that, minus 2 times the negative 1 plus 1. Well, this looks like negative 1 plus 2 plus 1. Well, that's just 3 minus 1. Ah, that's 2. Yeah. Check that out. That is consistent with what we found there. So either way, you get the vertex. What's step 3? Step 3, yeah, we're going to find the x and y intercepts. So to get the x-intercept, what do? I set y equal to 0. But what do I mean by y in this case? What do I mean by the y? Yeah, very good. So we say 0 is equal to negative x squared minus 2x plus 1. All right, you guys, how do I solve that? Does that factor? No, it doesn't factor. If I subtract 1, then am I still being able to solve for x? What type of function is that, you guys? It's a quadratic. How many ways can we solve a quadratic? We can factor, complete the square, quadratic formula, or graph, right? Those 4 ways, okay? However, this is why I'm going to advocate for this first way. Do you guys realize that this equation and this equation are the same thing? Do you realize that? Yes, one's in standard form, one's in general form. But check out that top one there. That top one's a lot easier to solve, I think. So I'm going to go ahead and replace this and say 0 equals negative 1 times x plus 1 squared plus 2. They are the same thing. This is easier to solve for because then I'd say, okay, well, negative 2 equals negative 1 times x plus 1 squared. Divide by negative 1. So I get 2 is equal to x plus 1 squared. I'll take the square root. Plus or minus the square root of 2 is equal to x plus 1. Hey, x is equal to negative 1 plus or minus the square root of 2. Look how easy that was. So I think another added benefit of going with that completing the square, if we can on these nice ones here, then you can easily get the x-intercept by solving for setting y equal to 0 and solving. Now, if you plug this into your calculator, you get 0.4 and you get negative 2.4. And we're going to need those because those are our decimals for when we graph the x-intercepts. All right, good. Let's get the y-intercept. How do I get the y-intercept? What do we do? Yeah, set x equal to 0 or evaluate f of 0, right? Well, this is pretty easy. Negative x squared minus 2x plus 1. Negative 0 squared minus 2 times, who cares? Plus 1. Oh, this is 1. Sweet. Awesome. Okay, so I've kind of highlighted quadrant 2 with a parabola opening down. Bless you. So we're going to start by putting the vertex on. We calculated the vertex at negative 1, 2. So please put a V for a vertex when you are placing your vertex on the graph. After you have the vertex, you know exactly where the axis of symmetry is. So that's going to be the line x equals negative 1. And we'll label that. I know that there's a y-intercept at 1. So this is the point 1. And because I have an axis of symmetry, and I am 1 unit to the right of the axis of symmetry, that means I'm going to be 1 unit to the left. There will also be a point guaranteed to be on there. Okay? And I also know that the x-intercepts are at 0.4, so that's like right about here, and at negative 2.4. That's probably right about there. So x-intercept there, x-intercept there, y-intercept here. That is all the information that I need to smoothly and accurately draw 6x minus 13. Okay, so with your families, please graph going through all those 5 steps there. Negative 3x squared plus 6x minus 13. And check it on your... Okay, here's what I want to talk about. All right, you should have found the vertex for this was at 1, negative 10. Correct? You should have also found that this parabola opens downward because of the negative 3. All right? Then, many of you were trying to solve for an x-intercept, and you were getting an imaginary solution. And I want you to make the connection. If my vertex is below the x-axis here, and it's opening downward, then it will never cross the x-axis. Therefore, there are no x-intercepts on the real number line, which is why you're getting imaginary solutions. My question to you is there another situation where this could also occur?
Yeah, if it's facing up and above the
Very good, Griffin, right? If my vertex is above the x-axis and it opens up, I will also get imaginary solutions in my algebra when I'm doing the work. The last thing that I want to connect with you is, tell me, what is the y-intercept, you guys? 0, negative 13. Anybody see a 13 over here? Or a negative 13 anywhere? Wow, it's there on the end. If it's in this form, if it's in ax squared plus bx plus c, then the c represents the y-intercept. All right? I wanted to point that out to you. Very good. Okay, last and final box for the day. We're going to talk about football players, okay? Let me go grab them. Last box is going to take a while. If I could grab these things. There we go, there we go, there we go. Here they come. Here they come. Boom. Okay, great. All right, check this out. My computer is so mad at me right now. Okay, can you guys see this picture? Can you see it? It's pretty good? All right, good. I want you to just look. Ladies and gentlemen, I need you to follow. We are in there, right? 0x squared. 1.1x engage with me when we do this. Okay? Once you have entered in this, that good. Abby, I think that's a 10. Nice job. Okay, ladies and gentlemen, the vertex here, correct? That's what we were basically asking us for. We can get the x by plugging in negative b over to do that, and I now have confidence that you can do that. I want to show you how to use it on the calculator. Please hit second. There is the word calc right above there, in which you're going to calculate something. We're going to calculate maximum. That's what we're going to do. Trace. When you punch in second, we have maximum here. We're going to push enter. That brings us back to this screen. And the calculator is asking you for a round. What that means is you need to move this little flash to the left of the graph. You do that by moving your cursor. Yep, I'm fun if you make noises as you do it. Okay, to the left, push, and you will see a triangle appear in the location. Okay? Now say, hey, give me a right bound. So you want the right of the highest. Okay, I'm definitely to the right. Push enter, and again, triangle. So basically, you're asking the calculator. Between these two triangles, calculate the highest point, the maximum. Do I want to guess? No, I don't want to guess. By pushing enter one time, and it locates it. Check it out. Is 36.1 feet in the air, and it happens 59 feet